This follows on from the video, How Does Focus Stacking Work? In this video, we are going to look at how we can measure the depth of field achieved with a given lens combination on our focus stacking setup. As a reminder, in the setup, the camera moves in steps towards the photographic subject. After each step, a photograph is taken. Each photograph has only a part of the subject in focus, because at this magnification, the depth of field is very shallow. At the end, all of the focused parts of the photographs are cut out and amalgamated into one photograph, in which the whole of the subject is in focus. In order for this amalgamation to work, we have to measure the depth of field of the lenses being used. If only a 20 micrometer stripe of the subject is in focus, then it is important that we don't move the camera more than about 15 micrometers between photographs. Otherwise, we will end up with a series of blurred stripes in the final composite photograph. Once the depth of field has been measured, we can then set the movement of the focus block to the correct length. Once the step length is set, we will end up with enough photographs to show all of the subject in focus. So how do we measure the depth of field? Well, the method that we have devised here is to use a stage micrometer, and I will now show how the work is done. First, we place a piece of blue tack on the stage. Then we stand the stage micrometer on top, with the flat face towards the camera lens. Here we are viewing the stage micrometer through a 50mm portrait lens on the camera body, which is on the focus block. We now switch to the 10x microscope objective. The stage micrometer has a ruler marked on it, which is 1 centimeter long. The ruler is subdivided into 100 parts, each of which is 100 micrometers long. We focus the image in the camera by turning the knob on the focus block to move the camera towards and away from the subject. From this current view, as it comes into focus, we can see that the sensor of the camera is seeing a frame that is about 35mm wide and about 25mm tall. This is the usual size of the sensor in a full-frame DSLR camera, as it was in older style 35mm film cameras. Showing this in diagram form, we can see the stage micrometer sitting perpendicular to the optical axis of the lens. Our next move will be to reseat the stage micrometer so that it is propped up on the blue tack at an angle of 45 degrees to the optical axis of the lens as shown in this diagram. Once the stage micrometer is in this position, then the depth of field becomes important, because only a small section of the ruler will be in focus. If we move the camera back and forwards relative to the subject, the part of the ruler that we see in focus will shift to the left or to the right in the image, as viewed from inside the camera. Looking at the graduations now through the 10x objective, we can see that only a tiny section is in focus. As we move the camera platform back and forth towards and away from the stage micrometer, the area of the ruler that is visible in sharp focus shifts to the left or the right accordingly. Our next step is to reseat the stage micrometer so that it is almost parallel to the optical axis of the camera lens. In this position, the length of the part of the ruler that is in focus will correspond almost exactly to the depth of field of the lens setup that we are using. We now set up the stage micrometer and look at it through the 10x objective to see what the approximate depth of field is. The part of the ruler in focus is now even thinner than it was with the stage micrometer at 45 degrees, but we still can see a small part in focus. Again, as we move the camera back and forth, the focused area of the ruler moves from left to right. It's quite hard to tell what the length of the focused area is in this photograph, so we now move to a still image that has been magnified, so that we can estimate the length of the focused area. This still image shows the focused area when the stage micrometer was set at 45 degrees, we can see that there is about a 100 micrometer length of the ruler in focus. Moving to a blown up image of the stage micrometer when it is nearly parallel to the optical axis, we can see that the depth of field is very small. It seems to me to be about 20 micrometers. Based on this measurement, I used steps of 17 micrometers to take the gametophyte fern photos that we have shown previously. This meant that I could take the smallest possible number of photos in the shortest possible time before the ferns rolled up under the heat of the flashlights. For more robust specimens, it might be better to go to 10 micrometer steps or even less to be sure of getting every area of the photograph in full focus. Here again is the final amalgamated photograph taken with 17 micrometer steps. This is the summary of how to measure the depth of field of a lens combination at this high magnification. The process can be repeated with ×5, ×20 and ×50 objectives. If you would like to know more about this project, please visit www.chlorophilosophy.uk.